Good evening, guys. Today's topic in digital electronics is Boolean expressions. Now, in this Boolean expressions or logical expressions, which we are going to see in this session, where these expressions are expressed in two forms. One is sum of products, other one is product of sums. These are the two ways through which we are going to express our Boolean expressions. So first we'll see sum of products, that is SOP. Now this is something which you need to remember whenever you are seeing sum of products or product of sum as POS. SOP is shorter form sum of for sum of products. Now sum of products recalls. Now this is something where you can see all product terms are summed up together here. These are some of the product terms which are summed up together to produce one expression. Now sum of products are represented using the numeric 1. Sum of products can be represented using numeric 1. Now you can see clearly how sum of products are represented under few examples. Now for example, this is the truth table which you are having output function as f. This is, you can see, output function as f, inputs as a and b. Now this particular row is telling me that f is 1 for a dash and b dash value. Now this particular value is telling it as a dash b. So my output function will be f is equal to a dash b dash plus a dash b. So this is what the expression, that is sum of products form, expressing the output value. Similarly, if I am having the other truth table, now this is the truth table. If I am having, you can clearly see my function. My function is telling output as a dash b dash plus a dash b. Now this is a dash b dash. Now this is a dash b. So this is how we represent our outputs for sum of products. Let us see now. This sum of products are called as minterms. These are called as minterms, and minterms are generally represented using ones on a particular thing. Now, like, though that what is that particular thing, we'll check it in the next session, but currently we'll see how these minterms we are going to represent using sum of products. See, now calculating the minterms now here. Now how these minterms are represented. Now you can see that if 0 is the decimal number and 0 can be represented as 000. Now this can be a dash b dash c dash, and which is represented using m naught. Similarly for 1 0 0 1, a dash b dash c and m1. Similarly, now this count will go till where? Till 7, that is 111, that is abc, that is m7. For now this minterm table is for 3 variable function. Now similarly the table for minterms for 4 variable will go from 0 to 50, that is 000 to 1111. So that is how we are going to represent the minterms on sum of product form. Let's get into sum of product form expression wise. Now if you are considering a 3 variable abc and f as output function, now you can clearly observe how I am representing the expression. Now if you observe clearly, for f function, wherever the f function is 1, I need to represent the output function. So that function, now this function will be what it is: a bar, b bar, c. Now what it is? 1. Now that is a bar, b, c bar. Now here 1 it is, that is a, b bar, c bar. Next function, where I am having my next function, you can see my next function is represented, that is only three terms are there. Now if you observe those three terms, m1, m2 and m4, m1, m2, m4, and that is what which is represented here, the same. So this is how you write the representation of output function. Wherever the output is 1, I am going to frame those using those literals, and I am going to tell my output function. Then, so this is how the representation goes. This is one more example of same kind. uh, let us write it here again for your sake. If you observe clearly the output function, now output function is here. Output function is a bar, a bar, b, c bar. Now this is a bar, b, no bar, a, b bar, c bar. This is A B bar C. Now this is A B C bar. This is A B C. Now when I'm adding all these things, I'm going to get my output function. Let us see. Am I having those literals at the output function or not? Now see, these are the five product terms which are there. See, those are all functions are represented here. Now this function can also be represented as M2, M4, M5, M6, M7 product. Or else I can also represent summation M of 2, 4, 5, 6, 7 as my minterm for representing the output function. So the representation goes in three forms. I can express using expression or using minterms or using those values 2, 4, 5, 6, 7 as my values. Okay, let's get on to the next thing. This is what related to sum of products. Now when we are seeing a like there are two forms under SOP, that is canonical form and standard form. Now canonical form, you can see that canonical SOP means canonical sum of products form. In this form each product term contains all literals, so these product terms are nothing but min terms. Hence canonical SOP form is sum of min terms. Means if I am having three variables as literals in my SOP, it should contain all the product terms should contain all the three literals. So such form we call it as canonical SOP form. Let us see the standard SOP form. Now see this here for the ABC as a function. Each term should contain all the literals like this. All the literals it should contain now. Now canonical form for A and B, so two variables are present. So this is what the example for canonical form. Coming to standard form, now if you see standard form, standard SOP form means standard sum of products. In this form each product term need not contain all literals. So the product term can be may not be a min term. Means I all the product terms may or may not contain all literals. Now if you see this f of ABC, in first term is AB, C is missing. In the second term A dash C, B is missing here. One third term B dash means A and B are both are missing. So this is a standard SOP form. You cannot call it as a standard. It cannot be called as a canonical form. Canonical form means each product term should contain all the literals. Whereas standard SOP form, it is a normal sum of product form. So this is what the difference makes canonical SOP and standard SOP form. And now these are few of the examples which are to be verified. Next we will get on to the concept of uh, product of sums. This is product of sums. Now if you observe clearly, some variables are producted. Now a dash b dash plus c, a plus b, b plus c, a plus b plus c dash, which are producted. Product operation is applied between them. So these terms are called as max terms. This, whereas SOP were called as min terms, these are called as max terms, and max terms are represented using zeros. Remember clearly, min terms are represented using ones, max terms are represented using zeros. Now how to find these max terms in the given variables? Now if you see clearly, max terms are represented in this particular way here. Now for example, if I am having a decimal value 0, the binary equivalent is a 000. Now max term is represented as a plus b plus c, whereas in min term it is represented as a dash dot b dash dot c dash. But whereas in max term, 0 is represented with normal variables, whereas 1 is represented as bar variables. Now these max terms are represented using capital M's, whereas min terms were represented using small m naught. Now these max terms are represented with capital suffix 0. Now for 1, 0, 0, 1, that is a plus b plus c dash. So 1 is represented with a dash, 0 is represented with normal. Now this is represented as m1. Now if I am taking 2, 0, 1, 0 means a plus b bar plus c. So 1 is represented with bar. Now it will be m2. So similarly the representation goes for remaining all other values which can be represented under decimal. Now this representation is for only the three variable terms, that is 1 1 1, that is a dash b dash c dash, that is m7. Similarly we are also, so now this is a function. Now if you observe this function clearly, the representation can be made like this. Now you can see f is a output function. F is output function. Now the f is 1 here, where at a plus B bar plus C bar. Now again this is at A plus B bar plus C bar. There is no bar here. Now again this is 1 at and this is 1 at A bar plus B plus C bar. So this is how we represent everything using those tables. Now if I come down, the same similar. Now if I am combining all things using product time, I am going to get this expression. Now I am going to represent using this literals, or I can have pi capital M of 0, 1, 4, 7 as my terms, or else I can use capital M representation also. So this is how we represent for product of sums. Now product of sums, again we are having standard form and canonical form, both the form. Canonical form means I should have all the literals in each sum term. There the product term, here the sum term. Sum term should contain all the literals of the given function, so that I am going to call this as canonical product of sum form. Whereas a standard form, coming to now, if you observe this particular two variables, now a plus b dot a plus b bar plus a bar plus b, it can all the sum terms contains two variables, so that's the reason I'm calling it as canonical form. Now standard form, each sum term may or may not contain all the literals, so those things we call it as standard POS form. Now if you observe this example, f of a b c d, first term is a plus b plus c bar, means a d is missing here. Dot a plus a d bar, now here b and c are missing. Next is a bar plus b plus a d, c is missing. So if the literal is present or not present, but it is giving us standard product of sums, then it is called as standard form. If I am having each sum term with all literals, then I am calling it as canonical product of sum form. So this is what the examples for sum of products and product of sums. Okay, we'll get into the next topic in the next session. So how to simplify this POS and SOP forms using corner map and tabular method. So two things we are going to discuss in the next session. Thank you so much.